Hi everyone. Distance learning assignment number 12. It is the law of cosines. So we just learned that the law of sines can be used for angle, angle, side, or angle, side, angle. Today, if you see the pattern side, angle, side, or side, 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 that's when you're going to use the law of cosines. So meaning the given information creates that pattern of side angle side or side side side. And we are not proving theorems or two triangles congruent. We are just going to solve for missing sides and angles of a triangle when it's not a right triangle. Because as you know, for a right triangle, you could find missing sides and angles using SOHCAHTOA, as well as use the Pythagorean theorem for missing sides. So when you don't have a right triangle, that's when you use the law of cosines when the given information and the missing piece, whether that be the side or the angle, creates the pattern side, angle, side, or side, side, side. So these are the formulas. Again, there's 3 different formulas that mean the same thing based on, are you solving for angle A? Are you solving for side A? Remember, lowercase is side, lowercase a is side A. Capital A is angle A. Are you solving for angle B? Then you would use this formula. Are you solving for side B? Then you would use that same formula as well. Are you solving for side C? Then you would use this last formula. Are you solving for angle C? You would use the same last formula. I want everyone to notice they're the same formulas. The point is there's 3 sides, there's 3 angles to a triangle. You can create the formula to work for you to find any of those. So basically, I just like to say to you guys, if you're solving for an angle, say it's angle A. The side across from it goes by itself and you square it. You equal it to the sum of the squares of the other 2 sides. So this part is Pythagorean theorem. But then because it's not a right triangle, you subtract out 2 times the angles on this side of the equal sign times the cosine of angle A. Okay, so I know it makes no sense right now, so we'll just do a couple of examples. All right, so we have given information. I'm going to label ABC. I always have a habit of starting that way. Side A, I know it's side A because it's lowercase, is 34, so that's across from angle A. Side B is 45. I know that's a side because it's lowercase and it's across from angle B. And the measure of angle C is 87 degrees. Find C, lowercase c, side C to the nearest tenth. So as you can see, side C is across from angle C. And check it out. My given information creates the pattern side, angle, side. Remember, side, angle, side is written this way with angle in the middle. So when you see the actual pattern in action, the angle is in the middle. All right, so what this means is these 2 guys are across from each other in the picture, right? The angle and its side. Check it out. They're across from each other in the formula as well. So the formula actually mirrors the picture. So what that means is you're solving for the side, so it's going to be c squared, right? Equals the sum of the squares of the other 2 sides. So 34 squared plus 45 squared in no particular order. But because it's not a right triangle, you subtract out 2 times the other sides, 34 times 45. And then you have the cosine of the angle across from the side. So look at the formula. Side C is across from angle C in the formula. It's across from each other in the picture as well. That will always be the case. So like I said, the formula and the picture mimic each other. They follow the same pattern. Okay, so then that's going to be cosine of 87. I like to put these brackets there to remind me that all that gets subtracted out. You don't have to. So if you guys would notice, this guy is always by itself. All the business is happening over here. So it's 34 squared plus 45 squared, 2 times those same two numbers, and then the cosine of whatever the angle is. So what you're doing is, you're literally just putting this in the calculator. I don't even need to write down anything. So what I'm talking about is, see what's on the paper? I'm literally going to type that out as is. So like literally the same thing. Okay, so then the end needs 2 parentheses because the one that opened was for the angle. And then I'm going to hit enter. So I'm getting 3020-ish, 0.85, blah, blah, blah. And because we're trying to solve for a side, it's a c squared. Just take the square root of it. So to make my life easy, I'm going to hit second answer. Oops, sorry. Second x squared, second answer. I'm sorry, my neighbor just decided to start weed whacking, so you just have to listen to that for a little bit. 54.96, blah, blah, blah. We're rounding to the nearest tenth. So this is going to have to be, what is that, 55.0, because the 9's going to round up. All right, so why are we doing the law of sines and law of cosines? Because we want, this is Algebra 2, we want to be able to find the missing sides and angles of all different triangles, not just the right triangles. Okay, so, oh, and this is the last one. There's no law of tangent. Okay, so it's law of sines, law of cosines, we're done. Okay, so that was finding the measure of a side. We're going to do one more. Number 2, find B. Now it says lowercase b, so that's how I know we're going to find a missing side. All right, let's do another one. I always tend to draw similar triangles. So it looks like labeling ABC. All right, find side B, so that means it's going to be this guy. If the measure of angle B is 18 degrees, not really drawn to scale here, I apologize, but just go with it. Side C is 72. I know it's a side because it's a lowercase, and side A is 100. Okay, so check this out. The pattern of the given information, again, is side, angle, side. That's how I know that we're using the law of cosines. And again, check it out. The missing side is across from the known angle. So while the formula is the same, we're going to use the b squared one. So like, check it out. It's going to be b squared plus the sum of the squares of the other two sides. So that means it's going to be 72 squared plus 100 squared, right? But I'm going to subtract out 2 times these guys, the 72 and the 100, because it's not a right triangle, right? Because this is the Pythagorean theorem. Can't use that because it's not a right triangle, times the cosine of the 18 degrees. All right, so if you guys would notice, it's pretty much the same as this. Square the two sides minus 2 times those same sides times the cosine of whatever the angle is. And it's always going to be cosine. All right, so it's b squared equals, I'm literally just going to type into my calculator what is on the paper. So it's going to be 72 squared plus 100 squared. That weed whacker is really annoying. It's like when we're in class and the maintenance department decides to mow the hill. But I don't have to close the windows. My windows are already closed. All right, so that's everything, right? Just got to make sure I didn't mistype anything. I think we're good. Hit enter. We're getting 1,488, etc. I like to write that down. You could skip this step. I mean, I just like to be as thorough as possible. And then because we're solving for the side, it's a b squared term, we have to take the square root of both sides. So I like to do second x squared, second negative sign. It puts the whole thing in there. So rounding to the nearest tenth brings me to 0.6, right? So that's finding the length of another side. All right. Oh no. Okay, sorry. I thought that I hit the record button. All right, so now, you guessed it, we're going to find the angles. So we're given ABC. So I always start at the left with A, ABC. All right. If side A is 18 degrees, lowercase a, side B, lowercase b, is 26. Oh, look at this one. Side C is 15. Find the measure of angle C. Oh, look at this. Check out the pattern. You're given side, side, side. That's how I know I should be using the law of cosines. So check it out. We're trying to find side C, right? So if we're trying to find side C, this is like how my brain works. I know, angle C. I know that it's here. Like, look at the formula. The angle is here. So we're looking for sides, I don't know why I keep saying that, for angle C. So the other side of the formula has to be side C squared. So then the rest of the formula follows as a squared plus b squared, but it's not a right triangle, so we're subtracting out 2 times these guys that get multiplied with our objective, the angle. So what I'm talking about is the 15 squared goes by itself. And then the other 2 guys. And why does that one go by itself? Because it's across from the angle of which we're trying to find. So that's done. That's by itself. Then we take 18 squared plus 26 squared, but because it's not a right triangle, we subtract out the 2 sides times 2 times the cosine of what we're trying to find, that angle. All right, so this I can't just put in the calculator. The reason I like to do the brackets is because this whole thing is isolated. It's its own term. This whole thing is isolated. It's its own term. It's separated by the subtraction sign. So 15 squared is 225. Know that off the top of my head. But I do not know what 18 squared plus 26 squared is. So 18 squared, hello, that's not right. 18 squared plus 26 squared is 1,000, so that's that. And then 2 times 18 times 26 is 936. Cosine C. All right, so if I dare say it, now that it's all simplified out, it's like solving a log equation. You have to isolate the term with the function. So while the function was logs back when, the function is cosine C. So I have to subtract the 1,000 to the other side. I just broke the point here. Okay, so then 225 minus the 1,000 gives you negative 775. Bring down the subtraction sign as the negative sign. All right, so now I'm here. Negative 775 equals negative 936 times the cosine of angle C. So in order to bring this number to the other side, the opposite operation needs to happen, which is division. So now I have negative 775 divided by negative 936. Of course it's not a nice number, guys. It's 0.827. Don't forget you could round to 4 decimal places and it won't affect anything. But you don't even need to do that, guys, because look, I put dot, dot, dot. Remember, you're trying to find an angle here. So in order to find the angle, you hit the second function in the calculator. You take the inverse, so second cosine of your answer, So I'm going to hit second cosine, second negative sign, and it types in that whole long decimal for me. So my answer is 34 degrees. Look at that. Because I was rounding to the nearest degree. So the ones where you're solving for an angle takes a little bit more work, as I'm sure you're noticing. The ones for the sides, these first two that we did, they were quick. Okay, so our last problem of the day, we are going to find to the nearest degree the measure of angle, of the greatest angle. Okay, so the greatest angle is always across from the longest side, right? So we got to figure that out. Side A, lowercase a, is 9. Lowercase b, or side B, is 10. And side C is 3. Oh, look at that. I have side, side, side. I want to find the greatest angle. So the greatest angle is going to have to be across from the longest side. So that is going to be angle B. All right. So these guys are across from each other, which means 10 is all by himself, which means angle B is on the other side of the picture. That means in my equation, angle B is literally on the other side of my equation. Remember, they mimic each other. So with that said, I take the sum of the squares of the other two sides, so the 3 squared and the 9 squared. Are you getting the hang of it yet? Oops. Bless you, Jack. Bless you. So, now, because it's not a right triangle, you minus out 2 times the 3 and the 9 and multiply that with cosine B. So now, again, we're solving for the angle. You could let it go into the next episode. Sorry, guys. So, clean this up. So 3 squared plus 9 squared, what is that, 90? Minus 2 times 3 times 9 is 54. I hope they like the next show, guys. So, again, it's like a log equation. You have to isolate the term with cosine. So we're going to subtract 90 on both sides. And now you bring the subtraction sign down as your negative sign. Does that make any sense? Because it's subtraction, you have to do the opposite operation. But now, negative 54 is being multiplied with cosine B. So, opposite operation is division. So you have 10 divided by negative 54, which is, of course, not a nice number. It's a repeating decimal. Oopsies. I'm just going to put dot, dot, dot. And it doesn't matter because I'm going to do all the work in the calculator. In order to find an angle, you hit the second button, and then because the function is cosine, and then I like to just use the calculator function of answer. Oops, so it's 10 divided by negative 54. Okay, so at this point, it's going to be second cosine, second negative sign. Get the answer in there. So this one is giving me, what am I rounding to? The nearest degree, 101 degrees, which is angle B. All right, so solving for a missing angle is definitely a longer process than solving for the side. All right, so we solved 2 triangles for a missing side in numbers 1 and 2. And we solved 2 triangles for missing angles in 3 and 4. I hope you stopped the video, you rewound. Let me know any questions that you have. This is the last topic of trig. Oh my goodness, I know, craziness, right? So we made it. We made it. All right, I hope you're having an okay day, and let me know if you have any questions. Bye.